the go live button just well, it totally disappeared last time, so we had to relaunch this Hangout again. But anyway, what's up, Russell?
Hi. Not much. I guess we're starting a bit late, but that's all right. What do we got for today?
So I was thinking, it's something major that happened all over, and it's not strictly AI, but this new not discovery, but reassertion of a discovery made like 100 years ago by the National Science Foundation, the American Science Foundation. Recently, have you heard the news?
I don't know. Why don't you tell me what it is, and I'll tell you if I've heard of it.
Yeah, so I didn't understand it much, but it's very intricate and very detailed. But basically, they they asserted a theory. Let's say that Einstein made more than 100 years ago about
Oh,
the.
you're talking about gravitational waves?
Yes, exactly.
Yes. Yes.
So for me at first, when I heard the news, I was like, duh. We already know this and we just asserted it. Come on, it took us like 100 year or so. And I was
Well, we
like,
weren't able to test it directly until LIGO was brought up to be good enough there.
yeah. And I mean, when I kept reading on what exactly they did, it became more clear that it was a really significant find and a significant experiment by itself.
Absolutely. And anyone who is interested should check out PBS Spacetime, which is a really awesome program on YouTube. And they did a couple things on gravitational waves and explained it pretty well. So
It's PBS.
it's called PBS Spacetime, but it's a YouTube channel.
Yeah,
It's
definitely.
actually a really awesome series. So I only recently discovered it, but I've watched a bunch of them.
Oh
Because
yeah,
they're
yeah,
awesome.
yeah. He pretty much explained it. He nailed it down. But the thing that amazed me most about this experiment that yeah, in every scientific experiment there is an aperture that they kind of devise to measure whatever variable out there to signify an achievement. So, in my simple understanding, what I did understand eventually is that they created a device, a sensor that,
Yeah.
and they accounted for all kinds of, let's say, what is it? All accounts of noise that is known to human experience. So, like radiation noise, earthquake noise, anything that sends a signal. So they account for all kinds of noise, and they cancel them out so they can isolate a very tiny specific signal coming from a major stellar event happening billions of light years away.
Yeah. So, well, the thing is that that's interesting is that it's not just noise because they're not measuring like electromagnetic waves. So this isn't like background radiation signals that they're trying to deal with interference of. What they're measuring is an actual ripple in space-time
Yes.
caused by hugely powerful gravitational wave. Like, so basically, what they're measuring is like binary stars that turned into black holes and started revolving around each other until they finally collapsed. That much mass and movement of mass through space and eventually, and not until even as massive as it is, it still doesn't matter until it starts revolving around each other incredibly fast. So with enough mass and enough speed of doing that, I guess, created waves in space-time that actually can be measured because of the way that it would stretch and squeeze space as a ripple of this gravitational wave
Yeah.
passes through it. And so they used lasers where they'd split the laser, and then I feel like it was like a 4 kilometer stretch before it would bounce back. And it always amazes me that they're able to even make stuff this perfect. But
Yeah.
like the lasers would split and then come back and then perfectly interfere with each other because it was a split laser and everything's exactly perfect. Like, how do you even make a 4 kilometer stretch exactly perfect
Yeah.
so that the wavelength of light would interfere perfectly? But they did. Uh, and then the idea is that because it's so big, this interference would collapse in a pattern that they expect if a gravitational wave passed through it.
Yeah, that's true. That's true. So, yeah, basically, this is like an oversimplification of what happens, but truly, it's simple if you think of the basic components and the logic of how to build an apparatus that um, detects this signal, why and how. The logic is very simple. It's the application is hard. Actually, building the apparatus is hard. But basically, they're using laser
Yeah.
because laser is just light, and light is basically magnetic waves and radio waves. So light is just two waves together. So they're splitting the waves, the magnetic and the radio wave, along 4 kilometers, and then coming back. So they're splitting them, and each end, the magnetic wave going on one end, and the radio wave is going on the other end, and each of them is hitting a very precise mirror at the end of the
Right.
tunnel, let's say.
Right. So yeah, I
And
mean, basically, the idea is like if you were to shoot a laser and look at its wavelength, the wave that the frequency of it, you know, basically, I guess two wavelengths hit each other in exactly the same frequency will cancel each other out, and by
exactly.
splitting it and having it bounce back, it is intended to cancel each other out perfectly.
Yes.
So
And
that's
you know what amazed me most is like, yeah, like all kinds of noise, earthquake noise, wind noise, radioactive noise, whatever noise they're canceling out, they had to account for the apparatus noise itself. So they're also considering the amount of noise that this mechanical apparatus produces to collect these noises.
Yeah. Well, yeah, and that is an interesting. I can see how you're starting to take that in as a notion of somewhat related almost to like some AI stuff. I don't
Yeah.
know. Is this where you're bringing it together? Is the noise? Yeah. Yeah. Because the fact is, like, if a truck drives by within like a mile, like it will affect the readout of this apparatus. And
Yeah.
so basically you say, well, how can you possibly measure this and know that it's a gravitational wave instead of just a truck driving by?
Exactly.
Yeah.
Exactly. And a smart point, which is also, it's not smart. It's, I don't know what's the word for it. It's kind of just to, because we know that we are humans, and we know that we tend to make mistakes all the time. So the simple way to avoid our stupidity is to actually build two of these Legos. It's an expensive
Yeah,
option,
and
but
we did, and that's exactly it. I
yeah,
am, yeah.
that's exactly how we make
I'm
sure.
reminded, and of course, this actually makes sense scientifically, but I'm reminded of the movie Contact. I don't know if you've
Uh-huh.
seen the movie. It's a great
Yeah,
movie.
absolutely. Yeah.
But they've got they receive transmissions from aliens, and so they're going to build thing. They don't even know what it is. It looks like a device to teleport or transport or spaceship or something.
Yeah.
And then someone blows one of them up, and it's like, haha, there's a secret. You know, us Americans, why build one when you can build two for twice the cost? Have one be secret that nobody knows about. So, that was a great line.
Yeah, but nonetheless, it was an amazing experiment. And what I liked the most is that they had everyone come in, announce it, and then explain it to the layman or the
Yeah,
average Joe.
yeah, and also they actually took a long time. It's interesting. They first noticed so the way I remember it is that they had one they built the thing, but it wasn't as sensitive as the current version is, right? So they built it, and they're like, well, let's just see. This won't see as far out into space, but we'll see what we can get. It's possible that none of these events, which would be strong enough for us to measure, is going to happen close enough for us to see from what we can see from here. And they ran it for a while, and they got nothing. So then they shut down for like 2 years or 3 years or something, so that they could like ramp up the sensitivity and make it better. I don't know. Maybe they went from 2 kilometers to 4 kilometers. I don't know. And and when they did that, they were going through their tests to see, basically like, all right, let's turn it on. And I don't know. I guess somehow they could turn it up sensitivity. I don't know. I'm probably oversimplifying it, but this is the way I heard it. That like they were on their last test, their last engineering test before they were officially going to turn it on.
Yeah.
And it was at full strength. And that's when they got their first readout that looked like it matched.
Yes.
It was like, and so you like, it was just interesting because they're just like looking at the engineer, like the data readout, where they're not expecting to see a gravitational wave. They're just like, all right, does this look right? Does it look like it's working? And they're like, oh, well, that's a gravitational wave. But they didn't announce it right away because they wanted to make sure. And presumably since then, they've already noticed more of these.
Mhm.
But again, they're trying to be very thorough before they announce them.
Yep. Yep.
So
And yeah, exactly the point you mentioned. It was very amazing because they had anticipated that this kind of event where two black holes merge into one happens once every 10,000 years, like
right.
for like so the probability of them
For some
seeing.
region of space, right?
Yeah,
So it's not once every 10,000 years in the whole universe. It's
yeah,
like
yeah.
once every 10,000 years per galaxy, I think.
Yes,
And so
yes,
it's like, how many galaxies can we be observing?
yeah,
Based on how sensitive it is, how far-reaching can
yeah.
we see? So that's what the interesting bit was.
It's really cool, like how I thought this was something unscientific about this specific experiment when, like in the press conference, like Russians came in, Japanese came in, everybody came in, and the only questions they were posing was like, how was the Japanese government? How did the Japanese
Oh, I
government
did notice
contribute?
that every reporter from like
Yeah,
their own country
yeah,
wanted to know how did their country's scientists
yeah,
contribute to this. It was like, just tell us how awesome Japan
yeah,
is,
exactly.
right?
Yeah. Yeah. So I thought it was really cool.
Oh, I think you just muted yourself.
Oh, sorry about that.
There you go.
I think that was the most unscientific thing about that. And,
But that's the
ironically,
reporters, right? It's
yeah,
not scientists doing that. It's
it,
reporters, and I'm
it
sure the
wasn't
scientists are rolling their eyes a little.
it wasn't the
But
space or the time to
no, it
actually
was
pose
neither the
that
space nor
question.
the time. Yeah. Yep. Pretty much. But
Yeah. So, as much as astrology, astronomy, and biology are advancing, I haven't actually heard of any major thing happening to AI for like 1 month. Everybody's just
Well, yeah, there was all of that. I mean, there was all that that news with what was that, like OpenAI? Was it called? It wasn't called OpenAI. Was it? Was that? What was that venture that uh what's his name from
sp-
Tesla?
yeah, the Elon Musk.
Yeah, Elon Musk.
Yeah,
He
yeah, the
did a thing.
open AI. Yeah,
Yeah.
everybody's kind of chipping in with his own version of, AI lab or AI
Yeah.
open source product. Use mine and whatever, dude. Uh, like, yeah, AI is just, I mean, no disrespect. Of course, open source can help a lot of people understand and improve, but then don't coin it under your wing and just claim it or whatever. I don't know
Yeah.
what is this. This is like marketing or I don't know what's this actually.
If you wanted to go for another tangent, since we don't have a lot of AI news, uh, the if you wanted to think, the other piece here, before we all get controlled by the Matrix,
Yeah.
um, VR has been in the news a lot lately because the Oculus Rift is finally shipping, and the HTC Vive is all set. So that's and that's actually an area that I think is really exciting, and only loosely related to AI in as much as it spells the end for all mankind. Um,
Mm. It's
That'd
really
be okay, boys.
exciting.
But
I mean, VR is exciting. Augmented reality is also exciting, but yeah, I don't know. I feel like okay, I kind of see the applications that can come in, but nothing really major. Like, yeah, we can use it in gaming a lot, and in some cool Google Glass applications, but
I mean, yes and no. I mean, I think I do. I mean, I think that clearly there's whole you know sci-fi. There's like a whole sci-fi genre of virtual reality. It's not just gaming. I mean, it's interesting. Like I in a way I'm really annoyed that you know Facebook bought Oculus because I was really excited about Oculus, and then Facebook bought it. Now I'm like, I don't know, because I'm not a huge fan of Facebook. But I think that the reason that Facebook bought it was not because they see a future in gaming. They see VR being, I don't know if they've read too many Neil Stephenson novels or whatever, but the fact is like the the power of VR for it's like I guess what I think is interesting is that we've become a very technology based society. I mean, look at us right now, right?
yeah.
Uh, Half a world away practically, and we're having a conversation about AI. You know, and the fact is we've got that. But the more we use Facebook and the more we use the internet and are connected all the time, I feel like we're also seeing like people don't know their neighbors or go outside anymore, and
Mhm.
VR is like doubling down on that. Like like okay, if we're gonna go in that direction, at least have it so that you could have a simulated experience of being near someone instead of talking to your computer monitor or checking on your phone. It's
Yeah.
like, I mean, it's an interesting prospect. And for some people, I mean, let's face it, the fact is that while, seeing people face to face, I think is important. I certainly wouldn't want to go down the road of living in VR and not experiencing the real world. The fact is that there's lots of things I will never experience in person. There are lots of people I would never meet in person, um, and especially for other people who are less capable of me, whether it's because they have less money than I do to travel, or because, they're wheelchair bound or rest home bound. I mean, I am looking forward to my future as a 90-year-old man plugged in to whatever virtual reality lets me still interact with a whole world of things instead of just like looking out a window all day.
Yeah.
So, I think there's some value to that.
Yeah, it's a little bit like sad the way you put it, but yeah, absolutely true. It will definitely help everyone, us and you know the unable or incapable. But at the end of the day, yeah, nothing beats seeing people person to person doing stuff on a first-hand basis. But then yeah, maybe it's not my niche or something. VR is I don't know. It's cool.
Yeah. Yeah. I don't know. I mean, it's certainly the sort of thing that, um, I don't know. When it comes to, I mean, for me, I will say this. I think, and maybe this is a perfect tie back, you know, um, here on a Code Newbie channel, just talking about programming in general. Um, for me, one of the things that I've always thought was kind of interesting is, and I know I'm not the first to make this analogy, but to me, being able to code, right, and writing code is like the closest thing human beings have to magic. Like, it is basically like you make something from nothing and it like makes things happen, right? And the limits of that magic is only bound by what can actually be controlled by code, which more and more things can be controlled by code. um, you know but still, real life is still real life, and you can't fly, or I don't know, whatever you'd want to do with magic. um, and yet, in a virtual world, that ceases to be the case. And truly, if you can, and I'm not saying that you'd be like, I give up on life in the real world, I want to live only in virtual reality, but to have experiences where it is boundless possibilities, and code is truly capable of doing anything. um, I think there's something really powerful and fascinating about that. As a programmer, I find it extra exciting, I guess. So, I don't know. Are you talking? Because I don't hear you. You got some dead air. Um, do you hear? Hmm, technical difficulties. I really don't. Well, I see you muting and unmuting. I know, and you're just talking like, I want to say something, but I can't. I don't hear you. I still don't hear you. Um, so I'll just keep talking, because it's just me. Um,
Hello?
oh, there we go.
Or maybe it was you that I don't know. Anyway, just
I didn't hear any of that, so I don't know what you're talking about.
okay, so I was saying that I read an article the other day about this Chinese gentleman who got married to a mechanical robotic doll. So
Oh.
actually, I think VR will satisfy. I wouldn't say, yeah, everybody with his own niche, let's say. So yeah, there is a demand, of course, for this. But then I also remember this awesome Pixar movie I watched of this lonely robot. I forget the
Yeah, yeah,
name.
yeah. Wally.
Wally, yeah,
Wally
Wally,
is great.
where he actually gets on like one of the human ships, and all
Oh,
the
I know. They're
humans.
all fat and they don't want to move, and they just fly around in a little. God, I think I just referenced that movie the other day. I think someone at work posted something about like a new the new trend. We talk about like standing desks. I have a standing desk, and
Uh-huh.
we've chatted about that before. And then I think someone posted like this new laying down desk where you don't even have to sit, you can lay down, and it just like the monitor is just over your head. And I don't know, it was between that and there was some other story, and I was like, the future, Wally is truly here,
Yeah,
where we lay
yeah.
down and don't move, and our
And actually, I loved Wall-E for many AI reasons. One of like of the peak moments of AI of Wall-E that brings out AI really in a subtle way and a very smart way is when Wall-E keeps collecting these junk basically and
Mhm.
putting them back at his place. So one day he picks up a spork, and then he runs his AI categorization algorithm. So should I put this with the spoons or should I put this with the forks? And then he's like, I don't know, and he just threw it. It's like, that's very true when it comes to uh, categorization algorithms. It's like, yeah, this is very confusing. Which one is which, or which one should it be? So Wally
Yeah.
is very an eye opener. I think even for kids, I consider myself to still be a kid, and I loved that movie.
Speaking of robots, if we did want to stay on the topic of robots,
Mhm.
did you see the latest videos from Boston Dynamics? They had that they had that robot. Everyone was making fun of it because in the video they were like hitting it with a hockey stick and like knocking the boxes around, and it just kept trying to pick them up. Um, and it was kind of funny, and everyone feels bad for it, but it's true that it's interesting. It's human-like looking, and it walks around on feet,
Mhm.
and it's a very capable robot. I know they had previously had a robot that was like this four-legged dog kind of thing that was really
Yeah,
big, and and uh, and
and
it
spiders
really
too.
it was really loud because it ran off of like a gas engine.
Yeah.
And I believe that the application so far that they had been working on, at least with that one, was uh, was actually for the military. It was for being
Uh-huh.
able to walk, for being able to have ground troops basically, and have a robot that could carry the load, but could handle the same type of terrain that a footed soldier could carry. And of course, what was really funny is I believe there was later news that were like, well, they canceled that project because it was too loud, and like you can't be very stealthy if you have a really loud gas engine running your robot. So you'll notice that the new robots they have are all electric.
That's really cool. I mean, in terms of robot failures, I think we have our fair share as humanity. We have our fair share on like some very funny public failures of robots, especially the Japanese Honda made robot
Yeah, the
Asimo.
Asima. Yeah,
Yeah, and
yeah. And this robot, I'll look it up. Let me see.
he kept
Uh,
failing and failing like on a huge public scale, and everybody like was expecting the
Atlas,
failure.
that's the new one. Atlas is very similar to Asima, uh, except I mean, it's not even intended to be like as smart. It's like it is a manual labor robot.
Mm.
Like it looks like it has like a radar. It kind of has like a spinning thing on its top, which is reminiscent of like the Google self-driving cars, and it looks like they had boxes with like QR code kind of. Or I don't think it was like actually QR code, but it had like designs on the box so that you could kind of like it probably could recognize that box as something. based on that. But it's like picking things up, and putting it on a shelf, and it could fall over and get back up again, and it can
Yeah.
push doors open and whatever. It's definitely not intended to be smart. Asimo is supposed to be like, oh, I can talk to people. This one's not. This is like, grunt, brute force labor
Yeah.
robot.
Asimo's main purpose was to mimic human walking. It's a simple thing, just to walk
Right.
and go upstairs, go downstairs. And the funny thing to me is that they always bring him up at,
Yeah, we can do that. I'm gonna get off in a minute. So
yep, I can't hear you. So anyway, what I was saying was Asimo, the Honda Japanese-made robot, the his main purpose was to actually just walk upstairs, walk downstairs, and just walk in a human fashion. And for a couple of years, every time they get him out for the public audience, and then and then he falls miserably. And then what was most funny to me is like they had this Japanese guy. They hired this Japanese guy who every time Asimi falls, he just goes and runs and then spread the curtains around the Asimo. Just oh yeah, just neglect what you just saw, and then he kept collecting Asimo's pieces. That was, I mean, yeah, I mean, yeah, poor Honda, but that was, I mean, super funny. Let's admit it.
that's what's so interesting about the Atlas robot, because the Atlas robot, other than the fact that like it's more meant for manual labor, whereas Asima, yeah, it's supposed to, again, it did start as like I need a walking robot, but like since then, a lot of the demos I've seen, it's like, well, it can dance or talk to you or follow you around or whatever, and this Atlas robot, I think. Yeah, I don't know. Again, I don't know if you've seen it, but it is basically a very similar purpose. Like it walks. It walks on two legs. It looks like a person. It has arms, but in addition to being able to walk around, it can walk in scenarios that I feel like Asimo would fail. Like you can see it walking around outside in the snow on like rocky, uneven terrain. There are times when it starts to fall or wobble, and
Yeah.
it corrects itself. And they even like have one scene where like they just push it like really hard so that it actually falls over and can't catch itself, and it like pops itself back up again, ninja style. And so
Is it
it's pretty
also
cool.
A Japanese?
No, it's Boston Dynamics, which I
I'm
guess would
sorry.
make
Yeah,
me think it's in Boston,
yeah,
but
yeah. Boston. I
it's
think
definitely
Boston
American.
University.
Yeah, I think it's Boston University. So it's pretty cool stuff. Um,
Yeah, they're doing some
but
cool research on robotics in Boston University. Really, really some cool stuff. What's really sad to me is that we are still very early on like the basic human stuff to do. Like I remember how sad it was. Now Japan being like one of the top countries in terms of AI and robotics, and then when the major earthquake hit in 2011, and then later followed the same day with a tsunami, and then
mm,
the nuclear plants had these problems, so they couldn't send people, humans inside.
yeah,
So at that point, Japan was just crippled. They couldn't do anything because they knew that their robotics is not capable of doing that stuff. I think the US helped with that, and they shipped some robots that can do some basic stuff. And I mean, yeah, that was to me that was sad. There
yeah.
is no real applications in real life are really solved until today by good capable AI and
We're
robots.
getting there. We're getting there. And to tie back again, the fact is that things like the Oculus Rift are going to start getting us to the point where you can mesh better, AI and things like, obviously, I mean, and again, I don't know if you want to call it AI because it's not I mean, some of the stuff, like specifically the Atlas robot, it's not smart in terms of like learning behavior necessarily, as it's, it's all of the things that we don't like consciously do, but our body and our brain and our nervous system and our muscles unconsciously do, having been trained in learning how to walk and balance and do all those things.
Yeah.
So you've got that in this robot, and hypothetically, were you to mount a 360 camera on top, and you'd obviously need a good enough feed, but you could then have someone wearing VR VR glasses and be able to control the robot as though they were the robot. I think you're going to start seeing stuff like that a lot.
Yeah,
Because the tech's just getting good enough to get there. But it's just about 6. I gotta go. I gotta get pizza for my kids. It was a good chat, and hopefully next time we'll have some more concrete AI things to talk about.
Yeah, I look forward to next time too. Thank you so much, Russell, for joining me, and
All right.
it's a pleasure as always.
All right. Thanks. Have a
Yeah,
good night.
bye. You too, bye.